Okay, so part C. When an alpha-emitting source above an ionization chamber grid was moved gradually away from the grid, the ionization current suddenly dropped to zero. Explain why the current suddenly dropped to zero. Okay, so first off, let's understand what's going on. So what we've got is some form of radioactive source that's a distance r away from our ionization chamber. Now our ionization chamber has basically got two plates, and there's your electrode going in through the middle, and this bit here is all just insulation, so they're not touching. And around from there then it's linked up, and let's go for a couple of, so actually make a battery, there you go. You got a battery and that's connected onto there. So this place is going to be positive, this piece is going to be negative based upon the arrangement of the battery. Oh, and I should have had in here some form of picoammeter, so basically a very, very, very sensitive ammeter. So how does this work? We've got alpha radiation, so alpha radiation, and it'll ionize atoms in the air within the ionization chamber. Okay, so when an alpha particle actually ionizes something, it removes electrons, they're actually sort of ripped off by the 2+ charge alpha, and that leaves behind positive ions. So if I've got a positive ion here left behind, that positive ion is going to be attracted to the negative electrode, which means you'll then get a current, minuscule current running all the way around. And every time it ionizes, you can get this tiny, tiny current. If there's constant ionization, you get a constant current running around that, though the current will be very small. So here, how do we explain that? Well, the positive ions move to the negative electrode, creating a small current through the, in this case it was labelled a picoammeter. Alright, cool. So we understand what's going on, but they said that what happens then is they move the source away. So they're going to be increasing R, so they're moving the source away, and suddenly the current is going to stop. So alpha has a range in air of a few centimetres, and we also know that alpha emitted from the same source or the same isotope has the same kinetic energy. Therefore, in uniform air, each of those is going to be able to make it a certain distance before it grabs those two, before it's run out of kinetic energy, grabs the last couple of electrons and turns into a helium atom. So, once the source is moved beyond a few centimetres from the ionization chamber, no alpha will actually make it into the said chamber. No alpha particles will reach the chamber. So the current stops. Now the reason it's suddenly is if it's uniform air, the alpha particles, all alpha particles, will suddenly stop reaching it. It's not like you can have one that reaches further and one that doesn't reach as far, because they all have the same amount of kinetic energy. So in uniform air, they would all reach the same distance. Once you go beyond that distance, that's it. No more ionisation in the ionisation chamber. No more current running around. Hopefully that helps. Thank you very much.